the shock was real. The giant gearbox gear, damaged in many places, prompted the Pakistani craftsmen to decide to create a brand new gear. This massive iron disc would serve as their material for the gear making. Due to its size, it exceeded the normal lathe's capacity, but they were determined to solve this issue. The craftsmen attached 4 auxiliary metal blocks to the iron disc, and after welding, moved it to the lathe. Using a homemade alignment pin, they conducted a coaxial test, and only after ensuring everything was correct did they tighten the chuck with confidence. Then, they began to turn the side surface. The lathe cut precisely and powerfully. Metal shavings fell like snowflakes. Under the cutting tool's action, the surface gradually became smooth. Since they were making a double gear, the craftsmen took out calipers, measured the slot positions accurately, and marked them. Following the marks, they began to turn out the separation slots, a lengthy process. Where the cutting tool worked, metal shavings flew out like noodles. Finally, a complete separation slot was finished. Next was the surface turning, similar to the side, but the grooves on top needed greater width and depth. During this process, several craftsmen worked together, with an apprentice helping to clear away the shavings. Under the craftsman's control, the cutting tool moved steadily along the predetermined path, the shape of the groove clearly emerging. Each cut was filled with strength and precision. Iron shavings flew out like a master sculptor at work. After more than 8 hours of meticulous machining, the grooves on the workpiece were perfectly presented. Once the craftsman confirmed the dimensions were correct, the apprentice cleared away the iron shavings on top. Now, it was time to turn the other side. But before that, the craftsman cut off the weld spots with a torch, then removed them with a sledgehammer. The workpiece was moved back to the lathe by crane. Since the other side already had standard grooves, no auxiliary metal blocks were needed, and the lathe's jaws could fix it precisely. Of course, the processing method for this side was identical to the previous one. For more accurate machining, the craftsman replaced the original cutting tool with a smaller one. Then, using calipers, they measured again, marking the groove positions. Once all the preparations were complete, the lathe turned again, machining the shaft seat to standard roundness. Next, they replicated the previous grooves, another lengthy process. After precise measurement and comparison with calipers, they obtained a standard gear, taking 3 full days. The semi-finished giant gear finally came into view. Next, the craftsman moved the workpiece to the milling machine by crane. To prevent the workpiece from loosening, they welded it after bolting it down. Using a straight edge, they precisely measured, marked the arrow slot positions and sizes, and the milling cutter went back and forth, iron shavings falling bit by bit. Although this process didn't require constant operation by the craftsman, as the bearing profile formed, another day passed. The next morning, the milled workpiece faced the most critical step. It was moved by crane again, and before milling the gears, the craftsman had to adjust the workpiece's position. They tapped it back into place with a sledgehammer, then supported the bottom with several bolts. The adjustment process was not simple. To prevent deviations in the milled teeth, they started the machine slowly, then tapped gently with a thick shaft, ensuring every part of the rotating workpiece was unbiased. Even a slight deviation could cause flaws in the teeth's shape and position, affecting the entire workpiece's quality and performance. After the adjustment, the craftsman tightened the bolts together. Still, they remained cautious. After the gear rolling machine made its first pass, the craftsman carefully checked the gear traces left behind, and only after confirming all positions were precise did the gear rolling machine truly start operating. The high-speed rolling cutter touched the workpiece slowly, beginning the milling of the teeth. Metal rubbed against metal, sparks flying. The workpiece rotated evenly, the rolling cutter cutting each part precisely, delicate teeth gradually taking shape. Of course, the formed gears were not yet up to standard, they still needed to be hardened. The craftsman placed the gear in the furnace, brought a pile of old clothes, then the blower started, and flames burst forth instantly. The gear turned red hot. The craftsman quickly retrieved it, and threw it into a pool, completing the quenching rapidly. The hardness of the quenched gear increased significantly. The testing instrument showed a hardness value of HS 37.7, fully meeting the standard requirements. Then, they exchanged the new gear for the old one, facing the large helical gear. Assembly was very difficult. After several unsuccessful attempts, the craftsman finally chose an effective freefall to disassemble the gear shaft. It was a success, and the craftsman smiled with satisfaction. Next, they inserted the old shaft into the new gear, cleverly hoisted a block of iron, then tapped it like a pendulum, gradually fitting the old shaft on. Finally, they placed the assembled helical gear into the large gearbox. After inspection, every tooth meshed precisely. It was truly shocking.